All right, so we're going to be graphing quadratics in vertex form. So you guys are going to be able to graph quadratics, but this time they're going to be written in a different form, okay? There's actually 3 ways that you can write a quadratic. One of them is standard, okay? That's what we did yesterday. Today we're doing vertex form, okay? And so in order to be able to graph quadratics in vertex form, you need to know what vertex form is. So vertex form is y equals a parenthesis x minus h squared plus k. That is vertex form for a quadratic. Now the reason why it's called vertex form is because when you're given an equation in that form, you're basically also given the vertex, okay? Here and here, your vertex are whatever in the H spot and whatever is in the K spot, okay? And you'll see a few different examples so you can kind of see what the form is once it's all written in and the values are plugged in. That A is the same A from standard form, okay? So the A kind of, goes along in all the different forms. So how do you graph a quadratic in vertex form? Well, you want to figure out what the vertex is. So identify the vertex and, of course, plot it. Okay? Identify the vertex, looking at vertex form and plot it. Afterwards, you can make a table and plot your points. Okay? You can either make a table then plot your points, or use the pattern. And then make sure that you reflect it on the other side of the axis of symmetry. Okay? So, nothing really has changed, just now it's a different form. We identify what the vertex is, and then we either make a table, plot our points, or use the pattern, making sure we get them on both sides. Okay? Let's look at these examples. All right? The scissors are there if you would like to cut those examples out individually. Okay? But just be careful, because I was told that if you cut along the dotted line, you might end up cutting along the graph. So you can either cut in between the spaces. It's up to you. That's why I said, you could get scissors if you like. Axis of symmetry. Shorthand. That was definitely not going to write that long thing. I feel like this is going to be real messy. So let's look at this first equation. We have x plus 3 squared minus 2. Okay? The first step is to actually identify what our vertex is. This is in vertex form. X minus h squared plus k. Now, do realize that whatever h is you have to plug it in. Whatever h is, you plug it into this general equation. So what did I plug into h to make it a plus 3 right there? I had to plug in a negative 3. So the x-coordinate of my vertex is going to be a negative 3. And then k is going to have to be a what? A little louder? A negative 2. So if you look at the vertex form of a quadratic and you look at what the vertex is, you can kind of say that, okay, well, it's going to be the opposite of what's on the inside and then whatever's on the outside. Yes?
So why is x negative 3?
Because of the standard form for vertex form of a quadratic. Not standard form, sorry, vertex form. Because it's a minus. So the only thing that's going to change that minus to a plus is a negative number. Okay? Any other questions? So we identify it and we plot it. So -3, -2. And then we can either make a table or we can follow the pattern. Okay? Which one would you like to do? Follow the pattern. Okay. I'll do the pattern for number 1. I might make a table for number 2 so you guys can see it both ways, because some people may not like the pattern. Some people may like the table, and I want to make sure I accommodate for both folks. So what is the pattern? Say it again. I go up 1 over 1. And then I go up 3 over 1. Can the next one fit? What's the next one? Up 5 over 1. So there's one side. After that, all I need to do is reflect it over my axis of symmetry to get the other side of the quadratic. So this point will be here. This point will be here. And then this point will be here. Try this again. So in number 2, we need to identify the vertex. What is the vertex? -1, +5. Remember, it's always the opposite of the inside. So that's where the -1 came from, and then the outside. So I identified it, and I'm going to plot it. 1, 2, 3, 4, 5. So it's going to be a max or a min. It's definitely going to be a max. A is negative. Just like before, if A was negative in standard form, it opens down. Same thing in vertex form. I'm going to make a table for this one. What are some good points to plug in this table? 0 and 1. That way I can just reflect them over. Okay? I plug them into my original equation doing order of operations. What's 0 plus 1? Squared times -2. -2 plus 5? 3. Okay. So 0, 3. When I plug in 1, what's 1 plus 1?
2.
Squared times -2 plus 5?
-3.
And I just copy those points over. That axis of symmetry. Making sure that my parabola looks like a U, not so much a V. Questions? All right. I want you to do the last one. Last one's on you. Okay, so as we look at number 3, we can see about the vertex that is going to be 2, -6. Because remember, it's the opposite of the inside. And so we're going to go ahead and plot that point, 2, -6. And we can, we're going to do this particular problem both ways. We're going to do it making the table, and then we're going to do it using the pattern, okay? So if we start by making the table, let's go ahead and create our X and Y chart. Since we know the vertex is at 2, then we probably want to pick a few points either to the left of that vertex or to the right. And so 2 points that we can pick that are to the right of that vertex would be 3 and 4. Okay, so when you plug in 3, 3 minus 2 is 1. 1 squared is 1. Take half and then subtract 6, and that's going to be -5.5. We're going to do the same thing for 4. When we plug in 4, 4 minus 2 is 2. Squared is 4. Half of 4 is 2. And then minus 6 should be a negative 4. Let me make that correction real quick. And so we'll plot those points. And when we plot these points, we'll be able to reflect it over the x-axis. You know what? Let's just go ahead and do one more. When we plug in 5, we're going to get that the y value after we plug in 5 and do the correct order of operations is going to be a negative 1.5. And so then we're going to go ahead and graph that point, reflect those points over the axis of symmetry, and we will have our quadratic. It is a minimum because a is positive, so it's going to point up. Now, if we use the pattern, remember the pattern is 1, 3, 5 normally. So up 1, up 3, and then up 5, always over 1. But no matter whatever the a value is, you have to multiply that pattern by the value of a if you want to use the pattern instead. So that means it's going to be 1/2, 3/2, or 1.5, and then 5/2, which is 2.5. Which means that from the vertex, no matter what, you always need the vertex. You go up 1/2 over 1, up 1.5, so 1.5 over 1, and then you go up 2.5, 2.5 over 1. The pattern still works no matter which way you do it, okay? So you need to take your values of a, and you multiply 1, 3, and 5 from the pattern by the value of a, and then it will tell you how to go about graphing your quadratic if you wanted to use the pattern instead. Okay? And so if we take a look at the 3 that we've done in this foldable, is there anything that you notice between graphs number 1, 2, and 3? Any observations that you see about those 3 graphs? What about it? Oh, I just got bored with using F. Look at all 3 at the same time. Well, they all got to be square in order to be quadratics. I would think so.
Oh, I know.
It's the parabola shape is like.
Wait, I know.
You see how the first 2 graphs that they're like the exact like width looking thing.
Okay.
I don't know.
Interesting. Okay.
Is it like whenever you have a higher a, like it's smaller, and then I have like a half, it gets wider?
Do y'all see that?
Yeah.
The original, the a value, it's the same size as your parent function. Okay? It just got moved. But if you look at number 2, even though it's flipped over, doesn't that look a lot skinnier than that one?
Oh, yeah.
And then if you look at the last one, isn't this a lot wider than the first one? The a value Also, not only tells you if it's going to open up or down, but if it's going to be wider or narrower. Okay? So, what conclusion can you draw as well? So if A is big, like 2, 3, 4, 5, it's going to be what? It's going to be skinny. It's going to be narrower. But if it's like 1/2, 1/4, 1/3, it's going to be wider. Yes?
Is that like absolute value or just like in general?
It's like in general. The negative causes it to flip over. But I'm talking about like the actual like number of A, not the sign. Okay.